Okay, class, settle down. Can we start now? Right, are you okay today? Say hi. Right, very good. So let me start with a new chapter, which is chapter number 6, random sample and central limit theorem. Right. So last week we already looked at the joint probability distribution and joint probability density function. Right. So in this chapter, it relates to chapter number 4, which is special probability distribution, especially on normal distribution, binomial, and Poisson distribution. So I hope you still remember normal distribution, Poisson, and binomial. But before we go to that part, let's refresh some knowledge on chapter number 1 later on. So let me introduce you the learning outcome. At the end of this lesson, you should be able to describe the term of random sample, statistics, and sampling distribution, and understand the concept of central limit theorem. Use the central limit theorem to approximate sampling distribution of the sample mean, right? So now, let's refresh back our knowledge on chapter number 1, which is population. So still remember what is a population? All member in the target area of the study, right? So that is a population, right? So in statistical inquiry, you often need information about particular group. So this group known as population, it could be small, large, or even infinite lah. So the word population doesn't necessarily mean people. It can be item, object, and so on lah. This is an example. All students in the class, all students in UTP, all people age 75 and above, right? So means all member in the subject area lah. So to collect information about the population, you should carry out census or sample survey. So we can carry out census or sample survey. You still remember what is census? We collect all member in the population. That is a census lah. Sample survey means that we take some portion of this population. Right. So this is a definition of census. Every member of the population is surveyed. When the population is small, it could be very straightforward lah. If the population very large, then census may be impractical, right? So sample survey means that we take portion from the population. So collection of information by selecting group of population. Right, sample is a representative of the population. This can give indication of population characteristic of being studied. Right, if the population is already normal from normal distribution, so sample will be normal as well. So note this one, number 3, large sample will give more reliable information compared to small sample. This is normal lah, right? When you get more sample, then the data will be more accurate to predict the population, right? So as you want the sample to be representative, right, of the population, so the sample should come from random sample, right, by using random sampling techniques lah. So to eliminate the bias of selection, right? So random sample means that let me go to this part. Random sample means that every member in the population has equal chance of being selected, right? Every member in the population has an equal chance to be selected as sampling unit, right? So all possible sample size n has equal chance to be selected, being selected lah. So this is the random sample. So if item being selected replaced to the population before the next item selected, so then it can be appear more than one in sample lah. So this is what we call as sampling with replacement. Right, so if the selected is not replaced into the population, then this is known as sampling without replacement. So now, I think this one we already discussed thoroughly in chapter number 1, right? So parameter and statistic we also discussed in detail, chapter number 1. So let's refresh back our knowledge about parameter. So what is a parameter? It's a numerical measure from the population, right? So if you want to measure mean, mode, median, standard deviation, so parameter is from the population. Statistic without S is a numerical measure from sample, right? So let's look at this slide. Parameter, a quantity of interest that is property of unknown probability distribution, such as mean, variance of the probability distribution. So parameter normally are unknown, but we can estimate through statistic, right? Statistic, numerical measure, right? So statistic is a property from sample from of the sample from the population, such as mean, mode, median. Right? We already discussed this in chapter number 1, right? So the symbol of mean for sample is X bar. The symbol for mean for parameter is mu, right? Standard deviation for sample is S square. Variance for sample is S square. Variance for population is sigma square. Of course, mu should be equal. The formula should be same as statistic. But for standard deviation, right, it is slightly different from parameter and statistic. Right. Now let's look at this one, random sample. Right. So if x1, x2 until xn constitute a random sample from the population with mean equal to mu and variance equal to sigma square, then the expected of x bar will be equal to mu. This is the definition number 7. The variance of x bar is equal to sigma square over n. Let's say you have a population here, right? So you select one sample. This is sample number 1 with n1 equal to 10, for example. Then you measure the x bar for number 1. Let's say 2.3. Let's say you take another one as 2, sample number 2, and 2 equal to 10. X bar, let's say x bar 2 should be equal to 3.2, right? So we want to estimate the x bar from all sample, means a mean of all the sample, right? Means we take several sample and when we want to estimate the mean of the sample. So it should be expected of x bar equal to mu, right? So remember, x bar is equal to 1 over n summation of xi, right? So now, from here, we know that expected of x is also equal to mu, right? So let's prove this one. Expected of x bar is equal to expected of 1 over n summation of xi, where I from 1 until n, right? I equal to 1 until n. So this one should be, we can take out 1 over n outside, right? So expected x1 plus x2 plus until xn, right? So what we have here, 1 over n multiply with expected of x1 plus expected of x2 plus until expected of xn. So this one should be 1 over n mu plus until n mu, right? So this one should be n mu divided by n equal to mu. So we proved definition number 7 for expected of x bar. So we know that expected of x bar equal to mu. Right? So another condition, it says that variance of x bar is equal to sigma square over n. Right? So we know that from the previous statement, the variance of x is equal to, sorry, this is expected. The variance of x is equal to sigma square, right? So variance of x bar will be variance of 1 over n summation of xi, where I from 1 until n, right? So we take out the constant 1 over n square, variance of x1 plus x2 plus until xn, right? So this one should be 1 over n square multiply with variance of x1 plus variance of x2 plus until variance of xn. So this one should be 1 over n square multiply with sigma square plus sigma square until n sigma square. So it should be n sigma square over n square equal to sigma square over n. Right. So from this definition 7, if you are measuring the mean of the random sample, right, it should be mu, and the variance of random sample, right, x bar, it should be sigma square over n. All right. Boleh faham? Can you understand this one? Where? N square. The constant we take out from the variance should be square, right? So based on chapter number 3. Chapter number 3, yeah? Chapter number 2. Right. Right, okay. Done? This one clear, right? Belakang, you all clear? Right. So now let's look at definition 7. Sampling distribution is a tool that tells us how close the statistic to the parameter, right? So the probability distribution for all possible value of all statistics that result with when random sample of size n are repeatedly drawn from the population, right? So the probability distribution of given statistic based on random sample. So it should based on random sample to estimate the parameter, right? So this is an example that I already illustrated just now. We take some sample and we measure the mean, right? So it should be x bar would have a normal, if let's say if the populations come from normal distribution, the sample should also be normal distribution. Okay, so this is by definition lah. From population normal, sample should be normal, right? But population unknown distribution, sample we can approximate using central limit theorem if the sample size is large enough. Right, we will discuss on that later. Right, so definition number 9, consider a normal distribution with mean equal to mu and variance equal to sigma square. So X is having a normal distribution with mean equal to mu and variance equal to sigma square. Assume we are repeatedly take samples at a given size from this population and calculate the arithmetic mean, right? So each sample has its own average value, as I illustrated just now, right? So this distribution average is called as sampling distribution of sample mean. So X bar will also have mean equal to mu, variance equal to sigma square over n. So this is based on definition 7, right? So this is a new about sampling distribution, right? So there are two types of sample. Sample mean, which is X bar equal to summation of Xi divided by n. So this is what you already look at this formula in chapter number 1. And sample variance S square 1 over n minus 1 multiply with summation of Xi minus X bar square. This is also equal to summation of X square minus summation of X, and then you square only X, divided by n, everything divided by n minus 1, right? The denominator should be n minus 1 for sample, right? For population, we don't need to minus 1, okay? Population is the same formula, but the large denominator should be only n. Yeah? Okay? Boleh? Right. Let's look at example number 1. So this example just to prove sampling distribution is definition number 7. Right. So a die is thrown infinitely many times. So let X represent the number of spots showing on any throw. Find the probability distribution of X. So this one kita dah discuss in chapter number 2. Remember. So in the die we have 6 outcome. So the probability distribution of X will be 1, 2, 3, 4, 5, 6. Probability of X equal to X. This is 1, 2, 3, 4, 5, 6 total. So every point, every outcome have equal probability value, right? Which is 1 over 6. 1 over 6. So let's calculate the mean of X. Can you calculate the mean of X? Expected of X will be summation of X multiplied with probability of X equal to X. So this one should be 1 multiplied with 1 over 6 plus 2, 1 over 6 until 6, 1 over 6. So what is the value? 3.5, right? Okay. And then to calculate the variance of X, it should be expected of X square minus expected of X, and then you square. And remember again, this formula only applicable when you want to calculate the probability, variance from probability, right? So you need to calculate the expected of X square. Should be 1 square 1 over 6 plus 2 square 1 over 6 until 6 square 1 over 6. So this one should be proper. What is the value here? 15.17, right? So we take 2 decimal point. So the variance of X is 15.17 minus 3.5 square. So this one should be 2.92, right? 92. So this is the mean and variance for a single sample, right? Single random variable. Okay? Done? So on 30th June, right? You datang kelas, right? 30 hari bulan. Right? Tak datang? Sudah balik. But we have class. Right? Okay. Okay, online. But I online at kampung, so my internet very not good lah. Yeah. I will discuss with the HCA first lah. But I think online should be okay, right? For one day lah. Later I tak boleh nak. Alright, let's look at example number 2. Based on example 1, suppose we want to estimate mean from the x bar at a sample size of n equal to 2. So means that now we are taking 2 sample, right? Sample size equal to 2. So we want to estimate what is the distribution of x bar. So to do this, we can just apply the definition 7, where definition 7 says that expected of x bar is equal to mu. This is also equal to 3.5. Variance of x bar is equal to sigma square over n. So this one should be 2.92 divided by 2. So which is 1.46. Right. So if you want to prove this, right, you can draw joint probability distribution table. Right, you can draw joint probability distribution table where 6 on the column, 6 by row. Right? And you measure the mean for every cell. Right? So I'm not going to do that because it takes two times to tulis. But you can try. Now let's look at the next slide, which is central limit theorem. Yes. Sikit je. All right. So now let's look at next slide, which is central limit theorem. So let's look at this one. The first slide tadi kita tengok, when the population is already normal distribution, then the sample will be also normal distribution, right? So that is definition number 9, I think. Right now, for central limit theorem, if x1, x2 until xn constitute a random sample from an infinite population with a mean equal to mu and variance equal to sigma square, and with the moment generating function mxt, then the limiting distribution z x bar minus mu divided by sigma over square root of n is, as n approaching to infinity, is a standard normal distribution. So what central limit theorem tells us is when you have sample size approaching to infinity, means the sample size is large enough, so the population, the distribution is approximately to normal distribution, right? The central limit theorem says that when the sample size is large enough, so the distribution will be approximate to normal distribution. So let me prove to you with some example, right? Let's say I create a sample of 30 data, right? So I create a histogram. So kita akan nampak this one lah. This is a distribution, right? It's not really normal, right? When I increase the sample size to 50, right? So the distribution, mana tadi DP? Yeah, it's approaching to normal. When I increase more, let's say I move to this side, then this one, sini. So let's say I increase more to 100 sample, right? So the distribution is approaching to normal, right? When I increase more, let's say I increase to 1000, so it become normal distribution already. Right, this is what in central limit theorem try to tell us lah. Right, when the sample size is large enough, so the distribution will be approximately to normal distribution. Right, so the question is how large the sample should be. So some book was tadi kita tengok just now we already look at the sample size, right? When the starting is 30, is not really normal. When we increase more than 30, then it become approximate to normal, right? So we can take one threshold, right? So we take n more than or equal to 30 to approximate the normal distribution, to use or to apply central limit theorem lah, right? In central limit theorem says that we know that x bar is having x bar is capital normal with mu and sigma square over n. The normal z for single random variable, right? And mu sigma square, right? It should be x minus mu divided by sigma, right? So this is a standard deviation, right? So to use x bar, z would be x bar minus mu. This mu because the definition 7 expected of x bar equal to mu, right? Divide by the standard deviation. This is variance. Standard deviation is square root of sigma square over n. This is also equal to x bar minus mu sigma over square root of n. Right? Okay? Boleh? Can you understand this one? Boleh? Belakang macam mana? You all belakang? Belakang semua boleh ya? Right, let's look at example number 3. So a bottling machine can be regulated so that it discharges an average of mu ounce per bottle. Right, it has been observed that amount of fuel dispensed by machine is normally distributed. So this is already normal distributed with standard deviation equal to 1, right? So n equal to 9, right? So a sample of n equal to 9 fuel bottle is randomly selected from the output machine on a given day, right? The ounce of fuel are measured for each, right? Find the probability that sample mean will be within 0.3 ounce of the true mean for the chosen machine setting, right? So we know that the population is already normal. Sample will be also normal, right? So we can apply z equal to x bar minus mu divided by sigma over square root of n, right? So what we want to find is probability of y bar minus mu less than 0.3. So this is within, right? So it should be probability of negative 0.3 y bar minus mu 0.3, right? So from here, we know that sigma is equal to 1, n equal to 9, right? So we can approximate to normal distribution. This is already normal, right? So probability of negative 0.3 divided by 1 over square root of 9. This is Z. 0.3, 1 over square root of 9. Right? So we apply Z equal to x bar minus mu divided by sigma over square root of n. Right? So this one should be probability of negative 0.9 to 0.9. So this one should be probability of Z less than 0.9 minus probability of Z less than negative 0.9. So the value should be 0.6319. Okay? Boleh? Remember, we have two conditions here. When the population is already normal, the sample should be normal. We don't care about the sample size. Right? So if the distribution is unknown distribution, but the sample size is large enough, maybe we take more than 30, so we can approximate to normal distribution. Okay? Sudah? Don't forget to sign in your attendance. Okay, done. Let's look at example number 4. This one done. Example number 3 done. Good. So example number 4. Refer to example number 3. So how many observations should be included in the sample we reached y bar to be within 0.3 ounce of mu with a probability 0.9. So now we want to estimate n, right? So from example number 3, we know that sigma is equal to 1 ounce, right? So this one should be probability of y bar minus mu less than 0.3, which is probability of negative 0.3 y bar minus mu less than 0.3, right? This is equal to 0.95, right? Equal to 0.95. So this is the area that we want to 0.5 lah. So within the mean, so this is mean the tengah-tengah ni kan. So this is 0.95. This is the area outside 0.95. Right, this one should be 0.025. This is 0.025. Right, this is mean. So based on the statistical table, if the area covers 0.95 within between the mean, right, it should be 2 standard deviation. The accurate value should be 1.96. This is negative 1.96. Right. So we convert this to normal distribution. Probability of negative 0.3 divided by 1 over square root of n. This is Z. 0.3, 1 over square root of n. This is 0.95. So this area should be probability of negative 1.96 Z 1.96 equal to 0.95. Right? So you still remember 2 standard deviation, the 3 rule of normal distribution, right? Like 68, 95, 99.5, 99.7, right? So 1.96 is equal to 0.3 over 1 over square root of n, right? So equal to this, right? So we can find n should be equal to 43, 42.63. So it should be equal to 43. All right. Boleh? Okay. Right. Let's look at example number 5. So a random sample size n equal to 15 is drawn from the PDF FY 3 multiply 1 minus y square. Y is between 0 and 1. So let y bar equal to summation of y divided by 15. Use the central limit theorem to approximate the probability of y bar between 1 over 8 and 3 over 8. Right? So even the sample size is not large enough, it's not more than 30, but the question asks you to use central limit theorem, you use lah. Right? But we know that the standard rule is more than 30. Right? So now, so how to do this? First, we need to find, so we want to find the probability of 1 over 8 y bar 3 over 8, right? So to use central limit theorem, z equal to y bar minus mu divided by sigma over square root of n. So we know the value of n equal to 15. We don't know the value of mu, which is expected of y bar, right? And we also don't know the value of variance y bar. So we need to find what is the expected of x bar. So expected of x bar will be equal to expected of, so this is not x, this is y. This is y bar equal to expected of y, right? So to find expected of y, we need to integrate from 0 to 1, y multiply with 3, 1 minus y square with respect to y. So this one should be equal to 1 over 4 lah. Right? Okay. And then we want to find the variance of y bar. The variance of y bar will be the variance of y divided by n, right? Which is sigma square over n, right? Remember? So the variance of y is equal to expected of y square minus expected of y then u square. So integration of y square 3 1 minus y square dy minus 1 over 4 square from 0 to 1. So this one should be equal to 3 over 80. Right? So the variance of y bar will be 3 over 80 divided by 15. Right? Okay? Boleh faham? So we want to find probability of 1 over 8 y bar 3 over 8. Right? So this one should be probability of 1 over 8 minus mu is 1 over 4 divided by 3 over, this is variance, right? We need to taking a square root of 3 over 80 over 15. This is Z. Okay. So same goes to the next on the right hand side. 3 over 8 divide minus 1 over 4 divided by the standard error, which is 3 over 80 over 15. Boleh? This is different compared to chapter number 2, right? Chapter number 3, I think, normal distribution. Number 4, right? Chapter number 4, normal distribution, we just want to find the probability of X, right? This one, we want to find the probability of X bar, the sampling distribution. So this one should be probability of negative 2.5 Z 2.5. So probability of Z less than 2.5 minus probability of Z less than negative 2.5. So this one should be 0.9876. Okay? Right. Let's look at example number 6. You all okay, ka? Okay. I provide you a lot of example until example number. Wow. Banyaklah. But basically, today we just learn about the normal distribution, the sampling distribution. So just to make sure you understand the first part, and tomorrow we will learn about binomial and Poisson distribution. Okay? Banyak-banyak nanti you pening. Right? So example number 6. Soft drink vending machine set to so that the amount of drink dispensed is random variable with mean equal to 200 milliliters and standard deviation equal to 50 milliliters. So the probability, what is the probability that average amount dispensed of a random sample size 36, right? It at least 204 milliliters, right? So now we have mu equal to 200 and sigma equal to 15, right? So original distribution for that population, we don't know, it's unknown, right? It's not from normal, right? But the sample size is equal to 36. By using central limit theorem, when the sample size is more than or equal to 30, so approximate to normal, right? So probability of X bar more than or equal to 204. So this is what we want to find lah. Right? So we convert to Z because we can use central limit theorem. Probability of Z more than or equal to 204 minus 200 divided by 15 over square root of 36. Right, remember Z equal to X bar minus mu divided by sigma over square root of n. Right, so this one should be equal to probability of Z more than or equal to 1.6. 1 minus probability of Z less than 1.6 is equal to 0.0548. Okay, simple, right? So you like this type of question? Tak suka? Tak mau masuk dalam test? But this is the most easiest question, right? Tak mau. Nak susah. Right? Okay, done. Let's look at example number 7. Yes. All right. Example number 7. Worker employed a large service industry on have an average wage of 7 ringgit per hour. Right. So mean equal to 7 and standard deviation equal to 0.50. Right. So the industry has 64 worker. So N equal to 64. So this worker have average wage of 6.9 per hour. So X bar equal to 6.9. So it is reasonable to assume that wage of ethnic group is equivalent, so that random sample of worker this from those employed in the service industry. So we want to obtain the sample mean probability that sample mean less than or equal to 6.9. So probability of X bar less than or equal to 6.9. Can you calculate the value? Simple, right? Because n is more than or equal to 30. So we use central limit theorem, right? So this one should be probability of z less than or equal to 6.9 minus 7 divided by 0.5 over 8. Right? So this one is probability of z less than 1 negative 1.6. So it's the same example as previous 0.0548. Okay. Sudah done? Easy, right? So example number 8 and 9, you can do by yourself. So I'm giving you the answer. So this is probability of z less than 2. Example number 9 should be 0.0606. Right? So you try to do by yourself and make sure you got the answer same as me. This is less than 0.2, less than z less than 2. You need to find from the statistical table. Okay. Okay. Your class too fast, huh? Baru pukul 7. Oh, we should continue to normal binomial and Poisson. Okay. So let's look at example number 10. So a distribution with unknown mean has variance equal to 1.5. So we have variance sigma square equal to 1.5. Use central limit theorem to find how large a sample should be taken from the distribution in order the probability will be at least 0.95. So means that this is the area at least. So the area to the right is 0.95 and this is 0.05. So we want to find the sample. How many samples should be taken to get at least 0.95, right? Okay, so first, what is the value of Z here? Yeah, tengok dalam normal distribution table. Where is it? This one less than 0.05, right? Kita cari. Eh? 1.6, 1.645, right? 1.645. Okay. So 0.9 should be 1.645. Should be in the middle, right? So this one should be negative 1.9645, right? But if you look at this one, the sample mean will be within 0.5. So this is what we want to find. Probability of X bar minus mu less than 0.5, at least 0.95, right? So it should be probability of negative 0.5 X bar minus mu. This is a same example as example number berapa tadi? 2, 3, right? So this is 0.95. So since we want to find the value of X within mu, so the area that actually that we want to find is this area, 0.95. So this is 0.025, 0.025. This is negative 1.96, 1.96, right? So we convert to Z distribution, 0.5 divided by 1.5 over n, square root of n. And this is negative 0.5 divided by 1.5 over square root of n. Right? So we know that this is negative 1.96. This is also 1.96. So 1.96 equal to 0.5 divided by 1.5 over square root of n. N should be equal to how much? Huh? Oh, sorry. I salah tengok. Apa yang kita salah? What is the wrong? No. This is variance, right? So it should be the square root of the whole thing, this one lah. 1.5 over n, taking a square root. right? So n should be equal to 24. All right? Can? Boleh? Any questions so far? So, no question? All right, let's look at example number 11. Can you solve this question? Can you solve this question? So we have a Poisson distribution with a parameter lambda equal to 2. We want to use central limit theorem, right? To find the probability of Sn from between 120 and 160. So we know that Sn is equal to x1 plus x2 until xn. So n equal to 75. So x is having a Poisson distribution with lambda equal to 2. Right? So lambda means what? Lambda is also equal to mean. Lambda also equal to sigma square, the variance, right? So our n equal to 75. So we want to find the probability of Sn, right? So we need to estimate what is the expected of Sn. Expected of Sn is equal to expected of x1 plus x2 plus until xn. This is equal to n lambda, right? N lambda. Variance of Sn equal to variance of x1 plus x2 x2 until xn. So this one should be n lambda. Right. So Sn is having a normal distribution with n lambda. Right? So this one kalau kita, if you input the value, should be n equal to 75 multiplied with 2, 150, 150. Right? So probability of Sn between 150 and 160 will be probability of 120 minus 150 divided by square root of 150. So this is not a sample distribution, right? So this is just normal Z, right? So this is 160 minus 150 divided by square root of 150. So this one should be probability of negative 2.45 Z until 0.85. Probability of Z less than 0.85 minus probability of Z less than negative 2.45. So this is 0.7866. Okay. Any questions so far? Soalan? Okay. Soalan, any question? 25. Oh, boleh? Boleh? Take 5 minute rest. But we don't have much example left. Take 5 lah. Right. So today lecture I will upload into my YouTube channel. Nanti I bagi share link, okay? Right? Okay, can we continue? Boleh? Can we continue? Right. Dah lebih 5 minit dah ni. Right. Right. Just some examples saja. Just want to show to you. Then we finish lah. Right. The first part of chapter number 6. Okay. Right. Example number 12. The length of time people take to complete certain type of puzzle are normally distributed. So this is from normal distribution, right? With mean equal to 48 minutes and standard deviation equal to 15.6. A random variable X represent the time taken in minute by randomly chosen people to solve this type of puzzle. The time taken by random sample of 5 people are noted lah. So we know that from here, mu is equal to 48.8 and sigma square is sigma is equal to 15.6. So X is having a normal distribution 48.8 and 15.6 square, right? And our n here is equal to 5. So the mean X bar is calculated for each sample, right? So state the distribution of X bar giving the value of or any parameter. So we know that X bar is a sample, the population is normal. So from population is normal, sample is also normal, right? So this one should be also normal with mean equal to mu, which is 48.8, and variance should be 15.6 square over 5. right? Because by definition 7, x bar equal to mu, variance of x bar is equal to sigma squared over n. Right. This is when population normal, sample normal. And we want to calculate the probability of x bar less than 50. So this one is easy question, right? B, probability of x bar less than 50. So probability of z less than 50 minus 48.8 divided by square root of, 15.6 over square root of 5. So this one should be probability of z less than 0.172, right? 0.5683. Right, simple question, right? So basically this chapter tak susah, very simple, straightforward. Susah ke? If you understand the normal distribution, chapter number 4, then this one should be okay lah, right? Okay? Done? Right. Let's look at example number 13. Right, example number 13. So height of a new variety of sunflower can be modeled by normal distribution, right, with mean equal to 200 centimeter and the standard deviation 40, right? So height is having a normal distribution, mean equal to 200 and variance equal to 40 square, right? So a random sample of 50 is taken, the mean height is calculated. So find the probability that sample mean lies between 195 and 205. So n equal to 50, probability of x bar between 195 and 205. So this one should be probability of 195 minus the mean equal to 200 divided by standard deviation 40 over square root of 50. Right? So this is 205 minus 200 divided by 40 over square root of 50. So this one should be probability of negative 0.884 to 0.884. This one should be 0.6234. Okay? Right? And B, a total of 100 sample n equal to 100. Each of 50 observations are taken. So in how many of these would you expect the sample mean lie between 195, 205? So we just multiply by 100 lah. So 100 multiplied 0.6234, which is equal to 62. Right? Should be equal to 63, right? Okay. You want me to show more example? Right? Okay. All right, let's look at example number 14. This is the last example. Then we have tutorial. So example number 14, at a college, the weight of male student may be modeled by a normal distribution. So this is already normal distribution with mean equal to 70, standard deviation equal to 5. So X is having a normal, mean equal to 70, standard deviation 5 squared. Right? So we want to find a probability that the mean height of random sample equal to 4 is less than 65. So probability of X bar less than 65. Right? So this is a straightforward question. Probability of Z less than 65 minus 70 divided by standard deviation equal to 5 divided by the square root of 4. So this one should be probability of Z less than negative 2, which is equal to 0.0228. Okay. Right. For B, this is a very simple. A simple, right? B. Let's look at B. So probability of mean weight. So basically, this is weight lah, kan? Right. Salah tulis, you make a correction, right? Mean weight of random sample N less than 73 kilos is 0.9918. So we want to find the value of N. So probability of X bar less than 73 equal to 0.9918. So we want to find the value of N. Very simple. Probability of Z less than 73 minus 70 divided by 5 over square root of N equal to 0.9918. So basically the distribution will look like to the left, right? So this is mu. To the left, the area will be 0.9918. So the value of K here is, look at the statistical table, 0.9918. Where is it? Where is it? This one, 2.4, right? So K will be 2.4. So this one should be probability of Z less than 2.4 lah, equal to 0.9918. So we can find the value of N, right? 70. So 3 divided by 3N over 5 equal to 2.4. 2.4. Right, so N will be equal to 16. Right? Okay. Right, for tutorial number 1, I think you can do it by yourself, right? Or you want me to show? You want me to show or you want to do by yourself? Show juga. Right? Belakang tak mau, dah geleng kepala dah. So I give the answer lah. So this one should be apa yang kita nak cari this one? Probability of Probability of X bar more than 22 will be equal to 0.0026, right? For tutorial number 2, the answer will be 0.0132. You try by yourself. Huh? This is very simple and straightforward. Right. Tutorial number 3 should be equal to 0.9628. Tutorial number 4, I don't have the answer, but it's actually probability of X bar more than 23 to be probability of Z more than 1.4. You can find from the statistical table. Tutorial, then finish tutorial. So extra question, I have 1, 2, 3, and 4 extra question. Right. Okay. Boleh? So you try to do by yourself lah. Alright. Sudah? So tomorrow we will look into a binomial distribution and Poisson distribution. So please refresh back your knowledge on Poisson and binomial, right? Okay, thank you very much. Assalamualaikum.